Okay, I ended up not working on this yesterday, and the rest of my resistors came today, so I just finished those tonight. I still need to go through and check my couplet designs, or K-network designs, because I don't want to take this board out again. But anyway, one of the things I was going to point out was I had said that the two 50 and 51 were 580, not 470 like the schematic showed. But actually, after I took them out and took a closer look at them, I realized that they were actually 560s, which is what I ordered. Anyway, dirty little thing. I'll show you here, because like I said, when I pulled them out, I was like, I can't tell if this is gray or purple or I don't know. They look kind of periwinkle to me. So these are the two. These are the two 560s at the bottom. Let me zoom in here. You should be able to see that. And maybe it's just because I'm a little colorblind, but this color here, I couldn't tell if it was gray or purple, or violet, I mean. And it turns out to be violet because this is here a 56 that I took out the other day. So I had sifted through to find the same type of resistors that had gray on them, and actually didn't come across. I'm looking again. Oh, here we go. I don't know if that's the same brand, but the gray definitely looks gray. So anyhow, I'm gonna double check those components, and I guess I'll have to put them in, and I will be back shortly. Okay, everything is done that's going to be done on this board for now. I did leave a couple of components on here. They didn't test bad, and I didn't have the values, so and they're not. Ooh, excuse me, they're not. That's the second time I've done that to you. They're not so value critical that they should mess anything up. So I went ahead and replaced the networks. So I got the which one did I get? I got the vertical feedback, which is here, and the vertical integrator, which is here, and the sound discriminator, which is the tiny one right here, which is nothing more than just a resistor and a capacitor tied together, and the horizontal phase comparer, which is this one here. It's also the one that's got the bump on it, since it's got that big old cap in it, basically. And then we've got the sync separator and the horizontal oscillator network, which goes here, and this one is there, right? Sure, okay. Anyway, so I'm going to go ahead and put this board in and bring back the chassis. And I went through these again on the schematic and traced them out to make sure they're right. And I don't know if it really would have made any difference, but it made me feel more confident. So I went ahead and took some resistance readings between the pins and the pins that should have only read should have only read for capacitors. Anyway, it all matched up pretty much. The numbers weren't that off. The one that was off the most would be the one that I had said that I thought would be off, which is the vertical integrator, which is on this particular set is the one where they added an extra 600. They tacked on an extra 600 picofarads in parallel. Oh, did it again. On with the 31500s at the end. So of course, this one came out reading 12 nanofarads, where well, this one was 9 or 10, and the one I did was 12. So that calculated out too. So again, I don't know if that makes any difference, but at least I know all the pins are connected and they have the same resistance. So, or similar resistance, I'm sorry. These were all a little bit high, but not really that high. In fact, I bet these aren't bad, to be honest with you. I'll bet they're not at all. Because the person I bought the set from said that the last time he used it was in 2001. So it was about 16 or 17 years ago, and it hadn't been turned on in that long. So, and it worked. It just that the picture tube was getting dim. So, anyhow, there's one other thing I was going to do, and I totally forgot what it was now. Maybe if I turn the camera off and come back, and I'll show you. But what else did I do? Oh, this thing here. I wanted to go ahead and test that. So there is actually an instruction on how to test that, and I don't have it right here, so let me be right back. Okay, so I'm going to go ahead. The instructions from Philco on testing these is basically to set your VTVM on 10. What did I do with it? 10K, is this it? Yeah, there it is, okay. When servicing television receivers where the dual selenium phase compare, or the horizontal AGC, I guess is easier to say, a 20,000 ohm per volt meter is employed. On the 10K scale, the forward resistance meter connected in the same polarity as the diode should be a maximum of 6,000 ohms. The ratio of the forward resistance of the two diodes should be less than 2:1 on the 100K scale. The back resistance meter connected in reverse polarity to the diode should be a minimum of 2 mega ohms. The center conductor of the phase comparing unit is common negative. That we already knew. So I'm just going to go ahead and use these. I actually have two of them. And the reason why I pulled them both out is because they actually tested a little bit differently. Even though these use the same board, when you open these up, they have the same board in them, but they have different firmware. And this one's actually in color. I got this one a couple years ago, and I got this this one I got I got this when I was still in Texas, and I got this here. So I think this is 3 years and this is 2 years old. But anyway, this is the one I'm going to use because I don't have a 10K on my Fluke, and I don't want to warm up my VTVM because it takes a half an hour. So anyway, I'm going to go ahead and hook this up. And you definitely want to get this correct. I've already been playing around with this, so you definitely want to make sure you get 1, 2, and 3, and you get 2 in the middle, because otherwise it'll read it correctly, but it looks funny on the screen. Anyway, so I'm going to go ahead and hit the test button on this, let it do its thing. Oh, well, you know what? Sorry, I already discovered that the top of these leads is dirty, and it prevents a good reading. So the part that was buried into the socket down at the bottom is fine. Let's try that again. So the voltage range on here is, I mean, they're close. So I think you can see that. Interestingly, though, this one is not switching screens, but this one will. So this one will read in millivolts, and then it'll read the leakage in ohms. So this one reads the leakage in 20 mega ohms. Let's see. So this one is. I think I have these set up the same color scheme. Okay. It's in the middle. Little micro grabbers are pretty annoying. Okay. Alright, so I'm going to go ahead and press the button on this one, and I'm assuming you can see that as well. Alright, so this one reads both the diodes. Oh, it's not. Well, interestingly, when I tested this a little while ago, this one now doesn't want to switch screens either. When I tested this a while ago, this one was switching to a second screen, and it was saying that the reverse was 20 mega ohms. So I am going to replace this, just so you guys know. I just wanted to test it just because, I don't know, I guess it's fun. I do have some Schottky diodes around here somewhere. I was playing with them a little while ago as well, and I'm going to assume they got buried. Alright, so that's enough of that. Let me grab the chassis and actually, I guess what I could do here is I can go ahead and show you guys that the reverse on this does test in the mega ohms. Well, I guess it would be better if I guess it would be better if I did hook this up actually in reverse. What is this thing doing? How the heck did I test this before? Now I'm looking like a dumbass. Okay. Well, I could touch it and make it do it. Alright. Whatever, I'm wasting a lot of time here, so I promise this did test basically the way this said it should, but you know, not when anybody's watching. Alright, I will be right back. Okay, I'm back, and I didn't want to bother you with the boring details of removing the cover to the high voltage cage cover, but I did want to point out something that's kind of, you know, one of those Philco-isms. You know, one of those things that makes us think they didn't want anybody to work on their products. So this is removed by removing a screw here. There's a screw here that holds on the single cap, a screw that goes from the inside to here, two on top, one that holds the wire guide, and then there's this little fucker right here. So this door does not come off. It's riveted on one side, and then, you know, this side here moves. So I ended up having to remove the high voltage rectifier socket, and then I could get this in there with a 1/4 inch socket on it. So if anybody's going to be doing this, I recommend it, hopefully you either have a stubby nut driver set, an angled 1/4 inch, because this would not fit either, or one of those flexible extensions, which I don't have. But anyway, it's off now. Alright, so what I was going to say here was, zoom in a little bit. Okay, so we know that, this is the way I want to go. So we know that this can be easily replaced by just sticking a cap here and here. Now, on the schematic, oh, it is right here, okay. So on the schematic, this is C1 here. I'm looking at the SAMs at the moment, darn it, and I was trying to stick to the Philco. SAMs can be easier to read, as you guys know, but on the Philco, this is E. This is E. No, wrong one. Hold on. Sorry. On the Philco, this is E2. There's only one section to it. So on the Philco, this is E2. Sorry, the Philco is different than on the Philco. They have the little section here for the rectified section when you have a 1042, 10L42 or 10L43, and it's, no, I guess it's set up right. In this instance, though, this one says E3-3, but this is E3, so it's kind of backwards, I think. Don't roll your eyes, I can hear you. Yep, this is E3, but I guess interestingly when you look at it, it says E3-3, even though there's only one section. They call the section 3. Well, that's confusing. Alright, so at any rate, so this is E3. It's connected between the rectifier number 1 and the positive section of the second 200 microfarad, which is part of the 4-section cap here. And when I was measuring these, funny thing, I think it's because these are in parallel, it reads funny, but I haven't disconnected any of this stuff yet. So I made the mistake of thinking that this red section here, Oh, I lost my remote. There it is. Okay. So I made the mistake of measuring the red section, and I saw this 211, and I thought, oh, that must be the right section. This is what happens when I do this stuff at 11 o'clock at night. And got very confused because I was trying to follow the wiring, and the wiring was not going where I wanted it to go, basically. And then I realized that maybe if I tried this other section down here, the one that actually connected where the schematic says it connected, that reads as 300, and I'm not sure if it's because these two are in parallel. Like I said, I have not disconnected any of the wiring, so anyway, so that's obviously that section. And the reason I don't know this is because when I cleaned the 2 millimeters worth of dust off of this thing, and then the crud, using alcohol, I managed to rub the ink off of the cap, so I can barely read what it says. So I have no hope of being able to read the symbols and what sections they're connected to, and I don't necessarily trust the schematic. So at any rate, so that little section there does connect in between here. It's the green wire, so it connects from, just like it says here, it connects on the wow, I'm lost now. It connects to the negative side of the one cap, as it should. And, oh, I see what I did. Ha 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 ha. I was thinking this cap here and this cap. I was totally missing this one down here. So now that you all are very confused, okay, so we have our two rectifiers here. So on the positive side of this rectifier, we have the positive section of this cap. And on the negative side of this rectifier, we are connected to the positive side of this cap over here. Where's my pointer? And then the negative goes to ground. So that's your voltage doubler, I'm assuming. And then we have a choke in between. So what I'm going to do then is I have a grounding lug here. Right. Okay, so we're going to connect one to replace this one. We're going to connect one here and one here. And then we're going to connect the positive of the second one here and the negative to this ground terminal over here is what we're going to do. Or I'm going to do. And you're going to watch. So, like I said, what I want to do is I want to eliminate this cap altogether. Pull that out from underneath. Temporarily I'm going to leave the wires because, as I said, I don't know if moving those caps from here onto that board, sharing grounding points with other components, are going to cause interference. I know that can happen when you're running on a tube amplifier. I've seen it. If any of you guys follow El Paso Tube Amp, he has a few demonstrations of that. So, I don't know where it is. I can see the fuses but not the holders. So I want to put a fuse holder in the spot where this goes because if I can make it down here right enough. because I can route the one section of I can route one section that comes out of here that goes to the fusible resistor, or old fusible resistor. I could route one to the fuse, and then from the fuse to here, and that way I can have my fuse and my resistors. So that is what I am planning on doing. And then I'll deal with this mess over here with the other 3 caps. And I believe, well, we'll wait till we get there. These sections, I don't know. I probably will put a terminal strip in there, but we'll see when we get there. So what I'm going to do now is babble, babble, babble. I don't like long videos. I get bored. So what I'm going to do now is I'll finish this up and I'll upload it, and then in the next video we'll see what I've done with the caps here and here, and hopefully I'll have a fuse in here, and then I will crack this open. So having all of this, having this cage out of here allows me to test this, which I did test, by the way. But since I didn't feel like unmounting the camera, and these 2 Sencors do that I have do ring tests, but the LC102 always tells me that every flyback is bad and every yoke is bad. Because it did it on the Hoffman as well. The Hoffman, it said, had 7 rings on it, and then the LC53 has a switch, and you switch the switch between 1, 2, 3, 4 different places, and you basically, whatever one, if one of them reads 10 rings or more, it's good. So on the LC53, I got 10 rings on one section here. When I tested the Hoffman, I got 7 rings on the LC102, and I got 11 rings on the LC53. So whatever. The Hoffman works. So I'm going to assume this one does. It ohmed out. All of the sections ohmed out where they were supposed to be, with the exception of this. The 400 ohm section on this one ohmed out to 367, I think, ohms, and I remember that the Hoffman did too, or rang out. I mean, ohmed out low. And then this will also give me the opportunity to replace the line filter cap and this 470K resistor. I kind of want to relocate this up towards the switch, but I may not, because I don't usually leave my TVs plugged in when I'm not using them, the old ones, or I have them on a power strip if they're on a shelf and the power strip gets shut off. And the ones in my bedroom are actually on one of the light switches controls several plugs sections. So anyhow, I'll think about that. Anyway, thanks for watching, and I'll see you in the next video.